Positively Perfect Problem Solving presents Discrete Relations and Functions. Welcome to Unit 4. This unit is going to be very different than the previous couple units we've done in the past. This unit deals a lot more with conceptual ideas than it does with particularly solving getting answers. So what I want to first introduce you guys to is the idea of a relationship between values. Numbers work together, right? It is truly like having a marriage or a friendship, something of that nature. So we actually use the word relation to describe that type of thing. So you guys have seen relations a lot. I'm going to go ahead and define that for you. So a relation is a set of ordered pairs. It's basically that simple. Anytime you have a set of ordered pairs, 3, 4, 5, 7, that's a relation because the X is somehow related to the Y in some way. They're connected, they're together, they're a pair. Okay? And in a relation, we can define it even further where we can say X is something called the input and Y is something we call the output. Okay? And we'll talk more a little bit about this later. Okay? We also have two other things that I want to talk about in terms of relationship. We're going to talk about relationships in terms of just two things, X's and Y's. So X's are always the inputs, and X's are also typically something called a domain. And we can call a domain all possible inputs. Okay? So X is our inputs. The domain is all of the possible inputs we can have in that relationship. The range, let me do different colors here because I think that might help us. So here, we'll make Y be red. The range is just all then possible outputs. And right now, this may not make any sense to you, but it will when I do a couple examples of what I mean. Right now, we're just kind of getting some language down, okay? The last piece of language we're going to talk about in this learning target, and I just give them to you all up front. Boom, right here, all the vocabulary we need. The last one is what a graph of a relationship might look like. So in this learning target, we're going to talk about discrete relationships, okay? Discrete. That's why this learning target is called discrete relations and functions. And what makes something discrete is that the graph has distinct unconnected points, like dot, 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 dot. Like here's a bunch of points. This is all discrete. None of them are connected. This is all discrete points on a graph. Okay? That's what discrete means. Okay? All right, let's just dive right into what I'm going to do with all of this, with this words. It's a lot of words here. Let's take a look at where I'm going. I'm going to the place that wants us to describe relations. So if I give you points, if I give you a graph, if I give you a bunch of different numbers, I want you to be able to describe what you're looking at using this given language. That's the goal of this learning target, okay? So I gave you all the language up front, and now we're going to talk about how I want you to use those words. So here's this example. This set of data represents the against and heights. I'm pretty sure that should be the word ages and heights. So none of you get suckers for this one, because I already see that that should say ages. Cool. All right. This set of data represents the ages and heights of boys given in years and inches. So all these coordinate pairs are telling us the age of a boy and his given height. So the first question I'm going to ask you before we look at the data is this a relationship? Is it a relation? If I go back to my definition of relation and I say a relation is a set of ordered pairs, boom, is this a set of ordered pairs? Yes. And we know because it is a set of ordered pairs. Don't overthink this. You guys know what ordered pairs are. I'm just now telling you when you have a set of them, like see how I've got, here, let me be a little more clear in what a set actually looks like. See this little, I'm trying to pick a color here. See this little squiggly bracket? Womp. And this guy right here, that is called set notation. So that, and it's going to become really important today. This is called set notation, and it's basically saying that anything between the two yellow bars is a set of something. So this is a relation because it's a set of a bunch of coordinate pairs. Okay, so yes, it's a relation. All right, the next question is now saying, what are the input values? Well, let's go back and look at our words. Input values are your x's. X's are input values. And so I'm going to go back and look at my coordinate pairs. Remembering, and I'll put it up here, when you have a coordinate pair, the x value is always first. So when I go here, 7, 8, 9, 10, another 10, 11, and 12, those are all my input values. Okay? Now, we call input values the domain, and I'm putting this answer first because I'm going to show you something really important. All those x values are called the domain. Okay, input and domain mean the same thing. But when I ask you to write the domain or to tell me what the input values are, we're going to use set notation for that because we're putting them all, it's a set of values. So I'm going to start off making a little squiggly bracket. Now, if you can't make this squiggly bracket because it took me years, just make a squiggle and I'll know what you mean. It does not have to be perfect, okay? But it does have to be a squiggle. It cannot be parentheses. So now I'm going to order them from least to greatest. So I'm going to write the 7 down. Then I'm going to put the 8. Then I'm going to put the 9. Then I'm going to put the 10. And then I see another 10, but I'm not going to list it in here because there's no point. I'm already telling you that the number 10 is part of the set. I don't need to tell you that 10 is there again. I just need to know that 10 is a value that exists. I don't need to know how many 10s there are. Okay, so I'm not going to list it twice. Then I have 11, and then finally I have 12. So that completes my domain. It completes my set of input values. Okay, I'm even going to make a little note here off to the side for you to copy down. Don't list inputs or outputs really more than once. So you might want to write that somewhere on your paper. And if you don't write it down and then I see that you did it and I look back and point at your notes and you didn't write it down, we're going to have a bad time. Don't do that. Okay, so that's my domain. That's how I write my domain with that set of notation. Okay. Now let's take a look at our output values. Output values, if you've forgotten, and I know you have, output values are your y's. So y is all of the output values. So I'm going to go back to my relation, and now I'm going to look at all my y values. I'm going to underline them. There's one, there's the other. I'm doing it in purple to show you. We call all these output values the range. And when I want to write my output values, I want to write my range, I'm also going to use squiggly brackets. Okay, and I'm going to write them in least to greatest. Now, this is a very convenient problem in that they're all in least to greatest already, but that's something going forward you'll also have to keep in mind. Okay, so I'm going to start with the 41, then 45, then I have a 49, then I have a 52, a 53, 55, and I'm running out of room. I'm going to write over here and then finish it with a squiggly bracket. Okay, again, squiggly brackets are important. I'm going to highlight them in my notes here as well. See, squiggly bracket, squiggly bracket, squiggly bracket, and squiggly bracket. Really important that you have your squiggly brackets. I'm going to be kind of mean about it. They're not the same as parentheses, and they're not the same as square brackets. They are their own special bracket, and they are called, it's a set notation is what we call it. And if you're going to take Algebra 2, it's going to be extremely important you know that. Okay, so that's domain and range given a set of coordinate pairs, okay, a relation. So what does this look like visually? Well, we've got 3 different ways to visually show a relation. Okay, we've got a table, a graph, and a mapping diagram. You all should know how to take coordinate pairs and put them in a table. Like, for real. I feel like that's something we should know. But if you don't, that's okay. I'm going to remind you again. Let's take a look at each of our coordinate pairs. Remember that number is x and that number is y. So my first I'm going to fill out my table is put the 7 there and the 41 there. Voila, there, point put in the table. So I can take a relation and I can put it into a table. And then ideally, in a perfect land, you could take a table and you could put them into coordinate pairs. I believe this is something you've done in middle school. I really hope it is, but if not, you guys have time to learn and remember. So it's okay. Okay. Now we've done our table. That's still the same relation, by the way. This table is the same relation. We're just showing it in a different way. Remember, this whole learning target is describing relations in as many ways as we can. Okay, so I've just put it in a table. Now we can also put it in a graph. So remember that these are coordinate pairs so I can plot them, right? This axis is in fact, I'm going to do the same colors here. So this right here, that's my input, my ages, just like here. Okay, so along the horizontal axis is your input values. Along the y-axis are your output values. So it's color coordinated here. So height then is your output. So when we graph these coordinate pairs, you're just graphing them like normal. 741, you're gonna have to estimate for some of these. This is 741 is about right there. 845, oh, that's not 7, that's 5. Haha, no suckers either, guys, unless you paused it quick enough. All right, 741, that goes there. There, now we're right. 845 goes there. 949. Notice how I'm estimating. I'm not like quite putting it fully on the line because it's not quite the exact number, but I'm trying my best to be as close as possible. 1155 and 1259. So there are all my points. Okay. So that's graphing the relation of coordinate pairs. Okay. We're not going to use this yet. I just want you to be able to graph it. We're going to use it later. So just being able to plot these points and correctly and understanding what your inputs and outputs are is what I'm aiming for this learning target. Okay. The last thing I need us to do is to have a mapping diagram. A mapping diagram is not crazy. I don't know if you've done them before. Maybe you have, but you're going to put all of your values in each of these columns. Okay. You're going to map one to the other. So your ages are your options in your domain. Okay. When you write your options in the mapping diagram, the same thing holds true when you write it in your set notation. You do not repeat the 10. See how I've still got 10 listed twice up here? You only list it once in the mapping diagram. You only list it once in the domain. In the table, you have to list it twice to show it's two separate points, but in mapping and with domain, you do not need to do that. I know that's confusing, but that's just something you might have to have practice on to remember. Okay. So input values go there, and then output values are going to go with the height, and they're going to be listed the same way. Again, we don't repeat numbers if there were any to repeat. I didn't give you guys a whole lot of space here, huh? Well, I'm sorry. Kind of having a hard time and I write tiny. Okay, so fit them all in there. And now we're going to map. And what I mean by map is when you map something, like you want to find out how to get from something to another place, you're going from one point to another. So if I want to map the number 7, I want to figure out where I started at 7 and where 7 led me to. In the point, 7 led me to a 41. So I'm going to just draw a line to connect it. 8 led me to a 45. So there I'm mapping it. You don't do what I'm doing in the table. I'm just showing you to visualize, but don't do that. 9 goes with 49. Now 10 is where it gets tricky. Because notice that in 10, I have the same number goes to 2 different points. So that means that 10 is going to be mapped to the 52, and then I'm going to draw a separate line and map it to the 53. 11 gets mapped to the 55, and 12 gets mapped to the 59. Okay. The last question I want to ask about all this information is this a discrete graph? Now remember, we just talked about discrete. You probably don't remember, so I shouldn't say that. Remember when I drew all these little dots on the paper and I said a relation, the graph of relationship that has distinct unconnected points is called discrete. So if your graph has a bunch of dots, it's discrete. So now when we go back to this question that says, is this graph discrete? You can now answer this question with a yes. And how do you know? You know because all points are unconnected. Okay? Cool? Cool. All right. The next part of this lesson, if you want to pause right now and take a little bit of a break, I worry this video might be a little bit long. If you want to take a break right now, stand up and stretch, I recommend it. We've still got a huge chunk of info to go over, so take a break, pause, stand up, stretch, do your thing, and then come back to it. The next thing we have to talk about is a very special type of relation. So I told you that like anytime I give you a bunch of coordinate pairs in a group, that's called a relation, right? Well, that's a lot of possible coordinate pairs. It'd be like saying like all, people thrown together as a group. Well, that's true. I could put a bunch of different people in groups, but some groups are different than others. So we have a very special type of group, a special relation called a function. And what makes a function really special is that a function has a very unique relationship between its input and output values. In that, I'm going to type it first, which I just said out loud. Okay. It's a type of relationship, and this is really important, where each input has only one output. This sounds super simple, what I just wrote down, but it's actually very challenging to think about. So I'm going to give you 3 different ways that we can think about a function in the 3 different ways I've presented it before, in pairs, mapping, and graphs. How we can see what's a function and what isn't a function. Okay, so let's take a look at our basic relations, right? Here are 3 relations I've given you. I've given you this green one. I've given you, we'll color code these. Given you this purple one, and then I've given you, how about blue? A blue one. Okay, so I've given you 3 different relations. I know they're relations because they're just sets of coordinate pairs, cool. But now I want to know, maybe one of these relations is a special relation called a function. Okay, now I need that to mean that each input can only have one output. So if I look at the question I'm going to ask myself is, okay, let's take a look at green here. 4 is my input. 4 has an output of 7. Cool, that input has exactly one output. And then I'm going to ask myself, do I see any other 4s in the input area? Nope, that's a 2. That's a -3, and that's a 3. So I can conclude then that 4 only has one output of 7. 2 has an output of 1. Do I see another 2s here in my inputs? Nope, so we're good with that pair right there. In fact, I'll use check marks instead of the number 1, so it's less confusing. It may still be confusing, but that's okay. Okay, -3, that has an output of 6. Do we have any other -3s that have an output of something? Nope, so this is okay as well. And finally, the 3 has an output of 4. Nothing else has nothing. There's no other inputs of 3, so we're good there as well. So to answer this question for number 1, is this a function? The answer is yes. It's a function because each input only had one output. Okay, now I'm going to show you an example of what a relation that isn't a function, because I think that's more interesting than one that is a function. So let's take a look at the purple one. The purple one is not a function. I'm just going to spill the beans there. It's definitely not a function, and I'm going to show you why. I've got -1 as an input, and it matches up with a 6. Cool. You go -1. You are hanging out with 6. I've got the number 1, and it's hanging out with 3. But I noticed something else. I noticed that this one is hanging out with 7. that means my input of 1 is hanging out with 2 different people, which A, can't happen. Like if I've got one thing, I can't split it into 2 different, it's like saying I've got a person that wants to split into 2 different groups. Like I'm in group 1, can I suddenly go into both group 3 and 7 at the same time? No, that's not physically possible. This 1 right here is totally like breaking the rules. He's deciding to go into 2 different groups and he can't do that to himself. That is not okay. That's what makes purple not a function. In the green one, we didn't have that problem. Every little number had its own like group. 4 had the 7 group, 2 had the 1 group, -3 was 6, 3 was 4. We didn't have an input trying to like go be in 2 different places. That didn't happen. Now the blue one is also special. Okay, the blue one, if we take a look here, 1 is trying to be with group 5. I don't see another 1 trying to be a different group. In fact, all of these X's are different, so we don't have that problem of it not being a function. Like, we don't have it appearing twice and wanting to go hang out in 2 different places. However, I do want to draw your attention to this guy right here, the number 6. It's repeated in the Y in the range, but that is okay. It is okay if the Y or the range repeats. That's fine. It doesn't matter. Because if I'm number 2, I can go into group 6. If my cat is number 3, he can also go into group 6. It's okay if the 2 of us are different people going into the same group. It's not okay if I'm one person trying to go into 2 different groups. That doesn't make sense. So really try and think of it as like sense making. Try not to think of it as like a specific rule of this, every input has 1 output. You can't split an input into 2 different outputs. It won't work, okay? Also, a trick here is it can't have X repeated. That is one sneaky little trick I'll allow you to use to help you with this one, okay? Okay, 2 other ways we see functions. Oh, I left a lot of space for that. 2 other ways we see functions, that's in a graph and mapping. In a graph, you won't see any of these graphs in your learning target today. I'm showing you something today that it's necessary for you guys to kind of see what the point I'm trying to make, but notice that all of these graphs are connected with a line. All the graphs you're going to see are discrete. You're going to see the ones that look like this. You're not going to see these long line ones, but there's still a point I want to make here that will apply. So in a graph, we have something called the vertical line test. Okay, vertical line test. And it basically says that if you draw a vertical line through the graph, it should never touch more than once. Now, this basically means it shouldn't touch more than once for it to be a function. All of these graphs are real and they exist and they're a relationship. Like clearly all of these graphs represents a relation, but we're looking for functions. So what I mean by a vertical line going through is if I draw a vertical line, and remember that's an up and down one, how many times does it touch? It touches here and it touches here. So this is not a function. It's that simple. Here, I draw a line, it touches more than once, so it's also not a function. However, this guy, when I do that, oh, he only touched 1 time. I'm going to test it again because it might be that somewhere else it touches it twice, but just from eyeballing it, I think that this graph is a function because it only touches it 1 time. No matter where I draw my line, it's only touching it once. Okay, that's a function. It can only touch it 1 time with 1 vertical line. I'm just testing it multiple times to make sure. This guy here is tricky. I have to be sure I draw my vertical line. That's actually touching it 1, 2, 3 times, so it's definitely not a function. This dude is like already its own vertical line, and I'm touching that a lot of times, like all the time touching that, so that's definitely not a function. Vertical lines are never functions. This little v guy, who's actually called absolute value, I'm only touching him one time every time I go through him, so yes, that is a function. And same thing here, no matter how many lines I draw, I'm only touching that line once. So that is also a function. And then this last one, circles are actually not functions because when you do this line, it doesn't, it touches more than once. Now, the technical reason why, and I'm going to show you with a little picture here, because I think this is important, and even if you're bored, still important. If I draw a little, and you don't have to write this down if you don't want to, although I recommend it. If I make a dot, let's do it like there. So here's my little discrete graph, right? This is discrete. It's different than the ones I showed you because this has dots in it, right? How do I do a vertical line test through this when I don't have actually a vertical line? Well, you've got two options. One, you can kind of pretend you have a line. You can kind of, you know, draw a line through here and then like that and make up your own line. And then you could draw through it. Right? Then you could say, oh, okay, dot, 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 dot. Oops, right here and right here it touches twice, so no, not a function. You could do that. That is one way. Other way would make you a superior mathematician because the other way you're actually thinking about what a definition of a function is. Remember, a function is something where each input has only one output. And when I look at this graph, and I'm going to highlight that sneaky part right here, this is the sneaky part, right? That's the part that broke our vertical line test. Well, what does that part actually mean? That part is actually saying this coordinate point 2, 2. And in fact, let me use colors to make my point even more. I would actually write this down. This is kind of important now that I'm thinking about it. So that point is 2, 2. And the other point, this guy right here, is 2, 3. And I'm noticing a very big problem. I'm noticing that the number 2 is trying to be with the number 2 and it's trying to be with the number 3. The number 2 is trying to be with two different people, right? It's trying to be in two different places. 2 can't do that. That's not cool, right? The number 2 can only have one group to be in. It cannot be in two places at once. This is also true with time. If this represented time, say at 2 hours, after 2 years, I had $200. After 2 years, can I also have $300? No, you can't have two different things at the same time. So there's a lot of reasons why you can see graphs not being functions besides the vertical line test. The vertical line test is just one of them. Okay. Finally, the last type of way to see if something's a function is by mapping, and I think this one's the easiest one to look at. Really, for this one, you're just seeing that each input maps to one output. So right here, 3 goes to 4, 5 goes to 4, 7 goes to 8. They each go to 1, so it's okay, it's a function. The second one, 3 goes to 8, 5 goes to 4, 7 goes to 6. They each go to their own group. The problem here is this next one. 3 doesn't go to anyone, which is fine, like whatever, 3 can hang out. But 5 is both going to 4 and going to 6. That's not okay. Nope, that's not a function. And the last one is a function because, again, they're all going to the same group, but that's okay. 3 people can go to the same group, okay? But 1 person can't go to 2 different groups. That doesn't work that way, okay? So that's kind of the way to think about it. I know you've dealt with me now for a full 30 minutes, and I super appreciate that. If you need one more break, take it. Because I'm gonna need you for this last part here too. So I would take one more break. This is gonna be like a 2-day target probably. There's a lot going on here. So take a break, pause, and then we'll finish up when you come back. Okay, we got this. For every relation, you're going to answer the question, is it a function? Yes or no? And you're going to tell me the domain and range. That is mostly what this practice is about. So, first one, is this relationship a function? I have the wrong one selected. Let's go to the right one. You should be looking at this. Cool. All right. Is this a relation a function? It absolutely is a function because each of these numbers maps to a different output. Each input has its own output. And the domain here, remember your brackets. Your domain will be 10, 16, 17, and 20. Because remember, this is your domain. And then your range is just going to be the outputs, which is over here. Squiggly bracket, and then from least to greatest. Don't forget that. Sometimes they'll already be that way, but sometimes they won't. Cool. Domain and range, done. Next one, is this relationship a function? This relationship is not a function. It's not a function because the number 3 here has decided to both be a 4 and to both be a 5. Not cool. Number 3, you are not allowed to have 2 different y values, so no, not a function. However, it does still have a domain and range. The hard part about this one is that you may need to write your coordinate pairs. If you want to, you totally can. You can write them all out. The first one is 1, 5. I'm talking about this, like right here. I'm writing these coordinate pairs out. Your next one would be 2, 4. And then, of course, the 3s that are really breaking the rules here. And then 4, 4. And then 5, 5. You can write them all out. That's one way to do it. I personally can tell that my domain is 1, 2, 3, 4, 5 just because that's where all the dots are. But if you need the coordinate pairs to help you see 1, 2, 3, 4, and 5, then by all means do that. Range, I can see from this graph that the only y values are 4 and 5. Just because there's no other dots anywhere else. But if you need to underline these and notice that only 4 and 5 are in your y's, you can do that as well. So whatever method works for you, I just want your domain and range to be correct. Okay? All right, let's go back to, I put these in a weird order. So is this the next one? Yes. Is this relationship a function? It absolutely is a function because none of those x values are trying to be in 2 places at once. The domain, without wasting, not that I'm wasting your time, but to just try and save you guys some sanity, you could write all these coordinate pairs out, but your domain, one of your x values is 20. Then you've got a domain value of 30. You've got another domain value of somewhere between 30 and 40, so maybe like 50-ish. And then another domain value of 60 all the way at the end. Oh, wait, not 50. It's more like 39 or something. 30, 35-ish. Okay. Your range are your y values. So I see 50. I see about a 90-ish. It helps too to label this. Like right now, these aren't labeled, so it's kind of frustrating. Again, these aren't labeled, so there are going to be times you have to like use logic to figure these out. Here I'm going to estimate that's probably around 90, and then my last one's at 100. If you're confused on where I'm getting these, please ask me. We'll be sitting at my desk while you're working on it, so ask me where I got those numbers from. Okay. The next one is a table. Is this relationship a function? 40, I've got 2 classrooms, cool. 45, 3, 50, and goes with 4, so each input has its own output, so that is absolutely a function. The domain and range for this one is pretty straightforward. My range is the 2, 3, and the 4, and my domain is my 40, 45, and 50. Okay? Hey, we're almost done. You guys, you got this. You can do it. I believe in you. If I can figure out how to get my problems. Oh, there we go. Last one. Is this relationship a function? Take a second. Take a deep breath. What do you think? And it's a no, not a function. It is not a function because this joker of a -1 is trying to be both a 1 and be both a -2. He's like, no, look, guys, I can totally be both these things. Hate to break it to you, -1, but you really can't. So it's not going to function. Not a function. However, it does have a domain and range. Its domain Now this is tricky, least to greatest. Your smallest number in the domain is -2, then -1, then +3, and you do not repeat the -1. The same thing holds true for the range. -2 here is my smallest value. Then I've got 1. Even though 1's repeated twice, I'm only writing it once and then the 5. Those are things I would take off half points for. Finally, this last guy is a total disaster area. This is not a function in every way, shape, and form. This 8 wants to be 3 different things. He wants to be all kinds of things, and this 9 wants to be 2 things. Like, not a function in any type of way. It has a very small domain of 8, 9 squiggly bracket, and a pretty small range of -9, -6, -4, -3 squiggly bracket. And notice I went from least to greatest. Okay. Wow, guys, the longest video of the year right here. You've been great. If you're watching this when I'm not here today, hopefully the practice, if you have questions, Mrs. Wright can help you. If not, I will be back on Wednesday. You guys are awesome and fantastic, and have a great day.